Dr. D.K. Yadav, along with the course convener, Dr. Sushil Kumar Shukla, sir. So it is this workshop has been going to organize in the collaboration with the Uttar Pradesh University of Medical Sciences, FI, Etawah, and Science Tech Institute. So it's a really great privilege for all of us that our esteemed resource person, Dr. S.K. Yadav sir, is with us. And I'm happy to share one good news that Dr. S.K. Yadav has been awarded third consecutive Research and Academic Excellence Award, which has been given by the Vice Chancellor of Babasaheb Ambedkar University today. So let us congratulate to him because he is very dedicated researcher and academician. Thank you so much, sir, and thanks for always coming on this platform and for sharing your knowledge and experience. So, sir, we'll take session on cluster analysis today. Over to you, sir.
Okay, thank you, Dr. Yadav, Dr. Shukla sir, and Dr. Singh as well. And first of all, very happy Republic Day to all of you, along with the Basant Panchami as well. And many thanks to all of you, and with your blessings of the elders and love of youngers, I am just keeping the research ahead, and that's why this is output of that one. So we'll try to keep it up. Okay, so this was about today. So this is actually the practice of our university, that it gives the Research and Academic Excellence Award every year in different broad disciplines to the faculty members in different categories like professor, associate professor, and assistant professor. So it's a good initiative by the university to encourage the research among the faculty members. So, okay, as Dr. Yadav has told you all that today's session will be on cluster analysis. So I think let me share the screen and we'll be discussing the things, and later at last we'll be doing hands-on on SPSS. So whether my voice is clear to everyone?
Yes.
Is it visible to all of you?
Yes.
So, okay. Today we will be discussing one of the very important multivariate technique, and that is cluster analysis. And you might have studied the previous one similar to that one, and that is PCA, or say factor analysis, principal component analysis, or say factor analysis. So today we will be discussing the cluster analysis, and we will be comparing it to the factor analysis as well. So the first thing that comes into mind is cluster analysis.
Hello, Dr. Dhruven.
Yes, sir.
Sir, please unmute all participants. And,
yes. Just a minute.
Yeah.
I am just muting all the participants. Just a minute. Give me 1 second. Okay. Now, Dr. S.K. Yadav, please unmute yourself.
Okay. So whether am I audible now?
Yes.
Dr. Dharmen.
yes, बोलिए.
Make co-host Dr. S.K. Yadav sir and Dr. Sushil Kumar.
So बना दिया.
Yes.
Okay. So let me now share the screen. Let me put it on Slides mode. So, okay, we'll be discussing the cluster analysis, very similar to the principal component analysis or say factor analysis. And definitely we'll be comparing the two to make the difference between the two. So the first thing which comes into the mind is the cluster analysis. What is cluster analysis? So cluster analysis is a group of multivariate techniques whose primary purpose is to group objects, that is respondents, products or other entities based on the characteristic they possess. So here it is contrary to that factor analysis. In factor analysis, we group the different characteristics or say different variables, similar characteristics or similar variables. But here we group different similar units and similar on the basis of all the characteristics they are possessing. So this is the difference between the two. That is PCA or say factor analysis is based on the grouping of variables while it is based on the grouping of units. So it is a means of grouping records based upon attributes that make them similar. So if plotted geometrically, the object within the clusters will be close together while the distance between clusters will be farther apart, because that units having distance or say dissimilarity in the characteristics will be put in different clusters, different groups known as clusters. So what is cluster variate? The cluster variate represents a mathematical representation of the selected set of variables under consideration, which compares the object similarity. So here all the objects, all the units are compared on the basis of the all characteristics they are possessing or under consideration, all the variables, characteristics, attributes, whichever you call it. Okay, so this has been given in this slide that what is the difference between cluster analysis and factor analysis. So what we do in cluster analysis, it is the grouping of objects on the basis of different characteristics, while it is grouping of different characteristics. And here say the basis for cluster analysis is the distance, while the basis for this one, I mean measuring the measurement for similarity is distance in cluster sampling, cluster analysis, while in factor analysis it is correlation. So factor analysis, we form group of variables based on several people's or say units responses to those variables, and in contrast to cluster analysis, we group people based on their responses to several attributes or several characteristics or several variables. So there we are, if we are dealing with the different characteristics and say different and we are taking observations on different units, so we may perform first factor analysis and then we can perform the cluster analysis as well. So now what is the difference between cluster analysis and discriminant analysis? Because the three are having very similar characteristics, very similar I mean analysis. So in cluster analysis, you don't know who and what belongs to which group. Here in cluster analysis, we are not going to form particular say clusters, and we don't know which unit is going to going in which cluster. While in discriminant analysis, we require to know the group membership for the cases used to derive classification. So there we make the classification rule to put the different units in different groups in discriminant analysis. So these are some applications of I mean cluster analysis in psychiatry, where the characterization of patients on the basis of clusters of symptoms. So we deal there, we group different psycho patients on the basis of their characteristics or symptoms. So, and in biology, we used to find groups of genes on the basis of their function. So, on the basis of the functions of the cells or say genes, we classify or say we make the clusters. And in information retrieval, the World Wide Web, that is WWW, consists of billions of web pages and the results of a query. Suppose we search anything, say cluster analysis. So you will have different, a series, a sequence of outputs. So what it do the clustering on the basis of the similarity or say text analysis, say on the basis of the input you have given, and it make the sequence. So here the result of and the results of the query of a search engine can return thousands of pages. Clustering can be used to group these search results into a small number of clusters, each of which captures a particular aspect of the query. So you can then make the clusters on the basis of the similarity of the results of different outputs. For instance, a query of movie might return web pages grouped into categories such as reviews, trailers, stars, and theaters. Each category, say cluster, can be broken into subcategories or subclusters, producing a hierarchical structure that further assists a user's exploration of the query result. Further, we can explore the subgrouping there. Okay, so in climate, understanding the Earth's climate requires finding patterns in the atmosphere and ocean. To that end, cluster analysis has been applied to find patterns in the atmospheric pressure of polar regions and areas of ocean that have a significant impact on the land climate. Now, common role cluster analysis can play. The one thing what factor analysis does, it also does that it reduces the data, dimensionality reduction. So it is one of the dimension reduction method as well. So data reduction. The researcher may be faced with a large number of observations that can be meaningless unless classified into manageable groups. So this cluster analysis can perform this data reduction procedure objectively by reducing the information from an entire population to samples to information about specific groups. It means if we have a information in the population, we can make different clusters to make the information more clear. Now it may generate hypothesis as well. Cluster analysis is also useful when a researcher wishes to develop hypotheses concerning the nature of the data or to examine previous stated hypotheses. We can also perform some statements, or we can have some statement through this analysis, cluster analysis. Now, most common criticism of cluster analysis. So if there is any technique, so there is, I think, always some criticism there with that technique. So it is also, there is also some criticism with the cluster analysis, that cluster analysis is descriptive, atheoretical, and non-inferential. So cluster analysis has no statistical basis upon which to draw inferences from a sample to a population. It means on the basis of the estimates, we are not getting the estimates. It means we are not capable to get, the more and more efficient estimates of the parameter of the population under consideration. And many contend that it is only an exploratory technique. Nothing guarantees unique solutions, because if you are doing, changing the some characteristics or units, then the clusters and the unit among the clusters will be changed. So because the cluster membership for any number of solutions is dependent upon many elements of the procedure, and many different solutions can be obtained by varying one or more element. If you are changing putting it here and there, are some changing some characteristic, or say even you are increasing the number of units, then I mean cluster structure will be changed. So cluster analysis will always create clusters regardless of the actual existence of any structure in the data, whether it is structure or not. Say for the homogeneous population, it will I mean create clusters. So when using cluster analysis, the researcher is making an assumption of some structure among the objects. There must be some, say, heterogeneity type structure there in the population under consideration. The researcher should always remember that just because clusters can be found does not validate their existence. So only with strong conceptual support and then validation are the cluster potentially meaningful and relevant. So it is important to validate the formed clusters. And the third criticism with the cluster analysis is that the cluster solution is not generalizable. It is not generalized actually, because we are having more and more and different solutions. It is totally dependent upon the variables used as the basis for the similarity measures. If you are, I mean, increasing the variables or decreasing the variables, so you will get different outputs. So we cannot generalize it through some, I mean, on the basis of the characteristics in hand. So this criticism can be made against any statistical technique, but cluster analysis is generally considered more dependent on the measures. So definitely these all, I mean, this criticism is associated with any statistical technique, but since it is depending on different measures, different characteristics of the units, so definitely this is very strong criticism with the cluster analysis. So use to characterizing the objects, then other multivariate techniques with the cluster variate completely specified by the researcher. As a result, the researcher must be especially cognizant of the variables used in the analysis. So it depends on the researcher how many and which type of variable it is using for its analysis. So ensuring that they have a strong conceptual support. So the selection of variables must be on the basis of some strong conceptual support, theoretical support. Now these are some objectives of the cluster analysis. So cluster analysis is used for taxonomy description, that is identify groups within a data. Data is simplification, the ability to analyze groups of similar observations instead of all individual observations. And relationship identification, the simplified structure from cluster analysis portrays relationship not revealed otherwise. So by making different clusters, we are capable to reveal some special type of, I mean, relationship. So theoretical, conceptual, and practical considerations must be observed when selecting clustering variables for cluster analysis. So there must be, one should have these things in mind while selecting different clustering variables, that it's there should be a strong basis of theoretical, conceptual, and practical aspects of the area of research or say study. So only variables that relates specifically to objectives of the cluster analysis are included, and variables selected characterize the individuals objects being clustered. So they must be capable to characterize the individuals or units under consideration. And how does cluster analysis work? Now it is very important to know how it works. The primary objective of cluster analysis is to define the structure of the data by placing the most similar observations into groups. To accomplish this task, we must address three basic questions. how do we measure similarity? One thing. How do we form clusters? How we will be making the clusters? And what are the measures of similarity? And third one, how many groups do we form? How many clusters should be there to analyze the things? Now, what is meaning of similarity and how we will be measuring this similarity? So similarity represents the degree of correspondence among objects across all the characteristics. So on the basis of all characteristics, all variables or attributes which are closer to each other, then this will be the similarity, which is how they they are having correspondence. So degree of correspondence, degree of association. So used in the analysis, it is a set of rules that serves as criteria for grouping or separating items. So these are some set rules on the basis of which we will be able to distinguish among the units or between the units. Now, the one thing is the correlational measures, which we perform in factor analysis, less frequently used where large values of correlation coefficients do indicate similarity, and it is used while performing factor analysis or say principal component analysis. And distance measure is used in this cluster analysis, and why we use distance we'll be showing in next slide. Most often used as a measure of similarity, with higher values representing greater dissimilarity. So distance between cases, it will depend on the distance means less distance means similarity, and greater difference means dissimilarity. Here it is very clear from this picture why we use distance measure in cluster analysis, not the correlation. Correlation. So here you can say, we can observe, we can see that from both the graphs, the trend of the two variables are similar. You can say here that the trends are similar. So the correlation between the two variables are same for the two graphs, while the distance on every respective points is higher in this graph 2 than the graph 1. So both graphs have the same r equal to 1, perfectly same distance, equal distance at every point. But here the distance is lesser than the distance between or say among these points, which implies to have the same pattern, but the distances, they are not equal. Here it is much lesser than the distance between the any 2 points of these curves. So that is why we use distance measure in cluster analysis, while correlation matrix in factor analysis. So what are the distance measures? There are several distance measures available in the literature and available in the software as well, with specific characteristic, but different measures, distance measures are having some characteristics. So Euclidean distance very much used in the analysis, the most commonly recognized to as straight line distance, that is Euclidean. So here we take the distance between the observations for the same characteristic, and we get the square, sum of square for all the characteristics under consideration, and we take the square root of that. Now squared Euclidean distance, the sum of squared, so this square will be removed, square root will be removed there. The sum of square differences without taking the square root, this one. So this will be, just remove this square root. So this will be the squared Euclidean distance. Now city block or say Manhattan distance, Euclidean distance uses the sum of the variables absolute difference. Here we have taken the squares of the differences, but here we are taking the, so this is used while dealing with, say, some, if outliers are important, say extreme observations are important, and we cannot exclude them from the analysis, then in these situations this distance measure is important to use. Now Chebyshev distance, it is the maximum of the absolute differences what we have done in this, I mean, Manhattan distance. So this is the maximum of this maximum of these distances for different characteristics. So frequently used when working with the metric or say ordinal data, where we are applying just say ranks. And Mohalenbeek's distance is a generalized distance measure that accounts for the correlations among variables in a way that weights each variable equally. So here it is say weighted type distance measure, and where weights are equal for all the variables under consideration, or say all characteristics under consideration. So here we can visualize some different type of distance measures. Say this we have 2 points, say G and C. So here this is Euclidean distance, and this is say Manhattan distance, that is a city block distance. This one. So this and this perpendicular we get, and this is Chebyshev distance. Perpendicular to this one, and from this the beginning point. Now let us consider a simple example of marketing research. Say a person is having wish to conduct a research to determine market segments in a community based on patterns of loyalty to brands and stores. A small sample of 7 respondents is selected as a plot test. So here we have taken say 7 objects and only 2 characteristics. One loyalty to brand, and then store to small, and the store loyalty and brand. Say we are using 2 types of characteristics, store loyalty and brand loyalty. Store and brand loyalty. Of 7 respondents is selected as a pilot test of how cluster analysis is applied. 2 measures of loyalty, say V1, variable 1, store loyalty, and variable 2, brand loyalty, were measured for each respondent on 10-point scale, say 10-point Likert scale. So these are the scores on 10-point scale for all 7 respondents on the 2 characteristics, that is store loyalty and brand loyalty. So this is a scatter plot. So here we have taken, I mean, 1. This is only for the 2-dimensional case, and for multi-dimensional it is very hard to, I mean, plot. Maybe plotted for 3-dimensional case. So here we have taken 2 characteristics, V1 and brand loyalty, and say store loyalty, brand and store loyalty. So V1 is brand loyalty, store loyalty, and V2 is brand loyalty. So we can, I mean, A is having a score 3 and 2. So it is 3, 2. So you can have 3, 2. Then B is having 4, 5. So you can hear this 4 on this and 5 on this. So this way we can plot different observations for the characteristics under consideration. So we have taken 7 units. So all 7 units are plotted on the scatter diagram with the 2 characteristics. Okay, so how do we measure similarity? So proximity matrix for Euclidean distance between observations. So we have just applied this formula, Euclidean, this one is square root of this one. So you can have idea how we make this table. So these are the observations, say these are the units A, B, C, D, E, F, G, and here A, B, C, D, E, F, G. These are the, I mean, just we are making the matrix. So proximity matrix. So here we have not, because it is a symmetric matrix. So triangular symmetric. So we are not interested in, writing the same thing again. So this is lower triangular and upper triangular will be same as just you repeat it here. So now we calculate the Euclidean space, say for AB. So here A and B, if you are interested in say A and B. So A and B is having a distance of 3.162. So this is for one first characteristic. So here we can have this one. You can say here this V1 for A is 3 and V1 for B is 4. That is 3 minus 4, and for V2 it is 2 minus 5. So here we can have V1A is 3, V1B is 4, and V2A is 2, and V2B is 5. So this way we can have the value. And if we are having more and more characteristics, then we will add the square of their differences. So now Euclidean distance is 3.162. So this way this has been written here. The distance between the 2 points two units A and B. Now B and C we can have idea here. For B and C, for V1 it is say 4 4, it will be 0, and for V2 it is the 2. So the 2 square of the 2 is 4, so 2, the distance will be 2. So it is 2. So this way you can calculate all the distance, Euclidean distances among different units under consideration. So now how do we form clusters now? Now the basic question or very crucial question is how do we form the clusters? And next, how many clusters will be formed? So simple rule is that identify the two most similar or say closest observations not already in the same cluster and combine them. So we will be just combining the similar and similar and similar observations or say units, not observations, but here observation means units only. In say factor analysis, observations mean the observation on the variable or say characteristic, but here observations means the unit itself on the basis of all the characteristics. So we apply this rule repeatedly to generate a number of cluster solutions, starting with each observation as its own cluster. So we will be starting from say clusters with single units, and we will be adding the similar and similar clusters to everyone to make the appropriate clusters. And then combining two clusters at a time until all observations are in a single cluster. So this process is termed as hierarchical procedure because we do in the form of hierarchy. Because it moves in a stepwise fashion to form an entire range of cluster solutions. It is also a agglomerative method because clusters are formed by combining existing clusters. So it is also a cumulative method because we are just cumulating the clusters. Now here a very beautiful example is given in the table. How do we form clusters? So here we have just written the distances, say in a set minimum distance, unstructured observations. So these are the steps 1, 2, 3, 4, 5, and 6. Here we have, the how we will be doing, grouping. So here you can observe from this table that the distance, the minimum distance is between which two units. So here the first you search for the minimum distance, and minimum distance is 1.414, and it is between E and F. So it is between E and F. So first we will be adding E and F together to make a cluster having more than one units. So you can see here we have just made how many clusters are there? First, we have made 7 clusters having a single unit in every cluster. Now we will be adding or merging the clusters on the basis of the similarity, and similarity measure here in cluster analysis is the distance. So we will be looking for the shortest Euclidean distance and we will be merging the clusters. So here, as we have seen in this table that the minimum distance is 1.4 and it is between E and F. So E and F will be merged together. Okay, so here E and F has been merged, and you can see here that now the clusters are reduced to 6 only. Now we'll see the distance next is 2. So which units are having distance 2? So you can see here, it is this one, between E and G. So now G will be merged with the E and F. So you can see here. So now E is merged with the G. So now this G is merged with this cluster. So now the clusters are reduced to 5, that is A, B, C, D, and E, F, G. And these are the average distances within the cluster. These are the average distances within the cluster. So we will have eye on these average distances. We will be continuing to make the larger cluster till this average distance is not drastically changed. Where it will be changed drastically, we will be stopped there. So so now we will be looking for next cluster similar to E, F, G, or say other. So we will be looking the distance again for say 2. So you can see here that the 2 is between C and D. So C and D will be merged together. So C and D is merged together. Now again there is difference between B and C. It is 2. So now this B will be merged with this C and D. So now it is B, C, D. So now the 7 clusters are reduced to only 3. Say first is having single element A, and the second one having B, C, D, and third one having E, F, G. Now 3 clusters. And the average distance is 2.2, not very much more than that, 2.1, 2.1, 2.2. Now we'll see the distance more than 2. We'll start from the smallest, then we will be having greater and greater or larger and larger distance. So now it is 2.2. After 2, it is 2.2. So 2.2 is between E and B and E. So now B and E, since B is already merged with CD, BCD. So now E will be merged with and E is already in this group. So these 2 groups will be merged together. So now we have 2 clusters only, one having element to A and another having B, C, D, E, F, G. All rest 6 elements. So now the average distance is 2.8, very close to 3. So this is a jump from this 2.2 to 2.8. So here it is better to make 3 clusters. So here in step 1, 2, 3, and 4, the overall similarity measure, that is average distance, does not change substantially, which indicates that we are forming other clusters with essentially the same heterogeneity of the existing clusters. When we get to step 5, that is this one, we see a large increase. This indicates that joining cluster B, C, D and E, F, G results a single cluster that was marked less homogeneous. So heterogeneity is there because of the heterogeneity, average is increased. So it is better to stop here. Now, how many groups do we form? How many groups we should form? So therefore, the 3 cluster solutions of step 4 seems the most appropriate for a final cluster solution with 2 equal sized clusters BCD and EFG and a single outlying observation A. So this approach is particularly useful in identifying outliers such as observation A. It also depicts the relative size of varying clusters. Definitely we will be knowing how many units are in different clusters. Although it becomes unwieldy when the number of observations increases. If you are increasing the units, then it is not, very appropriate thing. So here we can have an idea that first we have in one step we have merged the 2 units E and F because of having the lesser distance, and then C. So say in step 2 we have merged C with E and F, and then in third step D and C were also having the distance 2. So D and C will were merged, and in fourth step, so B was having a 2.2 distance, so it was merged with the B and C group. This, and now these 2 groups are having similar, say 2.2 like that distance. So these 2 clusters were merged, and so and at last to make one cluster A will be merged. So A is having far distance from all the rest units. So this is dendrogram. We started merging with the least distance, and we keep on merging till a single cluster is made. So graphical representation or tree graph of the results of a hierarchical procedure, starting with each subjects as a separate cluster. Say every line is a separate cluster, but first we have merged ENF having the least distance 1.4. So at first step we have merged this one, and second step we have merged this with the G having 2 distance, and then at third these 2 C and D were merged, and at fourth stage it was having again 2 distance B. So B was merged with the CD, that is BCD in a group, and at fourth position, fifth step, having distance between these 2 clusters, say EFG and BCD, it was the distance I think 2.2. So it was merged, and at last it was having a larger distance. So at last it was merged with this larger cluster. So graphical representative graph of the results of a hierarchical procedure starting with each object as a separate cluster. The dendrogram shows graphically how the clusters are combined at each step of the procedure until all are contained in a single cluster. So step 1, step 2, step 3, step 4, then step 5, and last one, step 6. Now, what are the outliers and what should we do with them? So outliers can severely distort the representativeness of the results if they appear as structure, say cluster, as the case of A, say inconsistent with the objective. If it is not consistent with the objective, if it is not appropriate with the objective, then definitely it is going to distort the representativeness of the clusters, and they should be removed if the outliers represents aberrant observations, not representative of the population. If observations of small or insignificant segments within the population and of no interest to the research objectives, then they will be removed from the analysis. But in many situations, we do not remove them. For example, if say we are considering the blood pressure of different persons and the person having a high blood pressure, so it will not be removed from the analysis. It needs special attention, special care. So there we will be retaining it into the analysis and some robust measure will be applied there, or we will be augmenting the sample size. So they should be retained if undersampling or say poor representativeness of the relevant groups in the population, the sample should be augmented to ensure representativeness of these groups. So we should increase the sample size so that every type of unit in the population should be in the sample to represent the population. Now, how to detect the outliers? Outliers can be identified based on the similarity measures, and we have used different, we have discussed different similarity measures. So it is finding observations with large distances from all other observations, or graphic profile diagrams highlighting outlying cases and their appearances in cluster solutions as single member or say small clusters. Either the member clusters having only single member or with very less members, they will be identified as the outliers. Now, what should be the sample size? The researcher should ensure that the sample size is large enough to provide sufficient representation of all relevant groups of the population. So better you define the sample size. And if you are having sufficiently large, the analysis is going to be good. The researcher must therefore be confident that the obtained sample is representative of the population. Definitely, if you are having a sufficient or say larger sample, then it will be the well representative of the population under consideration. So if not so, then if we are dealing with different characteristics, say, so standardization there must be standardization of the variables or data there in hand. So clustering variables that have scales using widely differing numbers of scale points or that exhibit large differences in standard deviation should be standardized. So if we have standardized, then it will be a pure number. So no, such type of heterogeneity will be there. So the most common standardization conversion is Z score, that is normal score with mean 0 and variance 1. That's a standardization. Now deriving clusters, how we will be deriving different clusters, which is the purpose of the study. There are number of different methods that can be used to carry out a cluster analysis. These methods can be classified as hierarchical cluster analysis, non-hierarchical cluster analysis, and the combination of the two, that is two-way cluster analysis. Now we will be discussing the hierarchical cluster analysis, then non-hierarchical cluster analysis, and the combination, obviously the two will be two-step analysis, cluster analysis. So hierarchical cluster analysis is the stepwise procedure attempts to identify relatively homogeneous groups of cases based on the selected characteristics using an algorithm, either agglomerative or divisive. Either we add different clusters having single units, or you first merge first one, and how we merge different clusters on the basis of the similarity having lesser distance. And if you are putting all the units in say single cluster, and then you are dividing them on the basis of the largest or the larger and larger say distance, then this is known as divisive procedure. So this way there are two ways: either you club one by one, or you club all the things first and then divide them. So these are the two way, that is agglomerative and divisive. So resulting to a construction of the hierarchy or say tree-like structure that is very famous with the name dendrogram, depicting the formation of clusters. This is one of the most straightforward method. So HCA, hierarchical cluster analysis, are preferred when the sample size lies below 1000. Otherwise, we will go for the non-SCA. Now, two basic types of SCA are there, agglomerative and divisive. As we have, I have discussed, but we will be discussing. Algorithm defines how similarity is defined between multiple member clusters in the clustering process. Now, agglomerative algorithm, hierarchical procedure that begins with each object or observation in a separate cluster. As we have discussed, as we have seen in the previous example, that we have taken 7 cluster objects. So we have made first 7 clusters having the single observation or single object, and then we started merging the clusters having the lesser and lesser distance, that is similarity measure. So in each subsequent step, the 2 clusters that are most similar are combined to build a new aggregate cluster. The process is repeated until all objects are finally combined into a single cluster, as we have seen in dendrogram, from n clusters to 1 cluster. And contrary to this, in divisive algorithm, what we do? We do n clusters from 1 cluster, n clusters from 1 cluster. Here, from n clusters, we make 1 cluster. So similarity decreases during successive steps. Definitely similarity decreases because distance increases. So clusters cannot be split there. Now what we do in divisive algorithm, it begins with all objects in a single cluster, which is then divided at each step into 2 additional clusters that contains the most dissimilar objects, means having maximum distance. The single cluster is divided into 2 clusters, then one of these clusters is split further for a total of 3 clusters, then and more to make the clusters with single objects only. This continues until all observations are in a single member cluster. So from 1 cluster to n subclusters on the basis of the larger distance. Now this is dendrogram. You can see here, if you are using algorithm, this agglomerative method, then we first merge E and F in step 1, then G with E and F, that is step 2. Then step 3, the distance was 2 with C and D, between C and D, so they were merged. Then B was also having the distance 2 with C, so it was merged with the CDs in step 4. Then they both were having, I mean, any of they say B was having a distance of say 2.2 with E, then these 2 larger clusters were merged, and at last this A was merged with this larger cluster. So this is agglomerative method, and in divisive method we have this cluster, single cluster having all the objects, and then first A will be removed because it has the maximum distance. Then these 2 will be removed because this 5 at 5 step, because it is having distance 2.2, and then the clusters or say units having distance 2 will be removed, and then 1.4 at last. Now agglomerative algorithm, among numerous approaches, the 5 most popular agglomerative algorithms are there. One is single linkage, first one, then complete linkage, and it means These are the methods to decide the distance between two clusters. How we will be deciding the distance between the two clusters. So there are so many methods to decide the distance between the two clusters. The first one is single linkage, second complete linkage, third average linkage, fourth centroid method, Watt's method, and Mahalanobis method, distance method. So here see single, what is single linkage, also called the nearest neighbor method. It defines similarity between clusters as the shortest distance from any object in one cluster to any object in the another cluster. So here just these are two nearest points of the two clusters. So this distance will be the single linkage distance. So this will be used in as the distance between the two clusters. So now complete linkage, also known as farthest neighbor method. So in this method, the farthest 2 points of the two clusters are taken into consideration. So the oppositional approach to single linkage assumes that the distance between two clusters is based on the maximum distance between any two members in the two clusters. Here you can see this one and this one. Now, what is average linkage? The distance between two clusters is defined as the average distance between all pair of the two cluster members. So we will be starting from this point to this distance, this distance, this distance. Then this one with this point, with this point, with this point. This one with this point, with this point, with this point, and we will get the average of these distances. Now, centroid method. Centroid method is nothing but it is the distances of all these points, and we get the average of these observations for this cluster and average of these observations in this cluster, and then we take the distance between these two average points. That is why these are known as centroids. So cluster centroids. So what is this point? What is cluster centroid? So cluster centroids are the mean value of the observation on the variable of the cluster. Suppose we are just considering a particular variable, say V1, loyalty, stored loyalty. So we will be having the values of all stored loyalties for all the units, and we'll get a mean, arithmetic mean. And same for the another cluster, and then we'll be taking the distance. So similarly, we will have the distances for all the characteristics or say attributes under consideration for different units. And the distance between the two cluster equals the distance between two centroids. So for all characteristics, the distance for the centroids will be taken into consideration. Now, Watt's method. The similarity between two clusters is the sum of squares within the clusters summed over all variables. Say here we are having 3 units, but possessing say 15 variables, 15 characteristics, or say 2 characteristics. So we will be having the sum of squares for all the units for all the characteristics under consideration for this cluster and for this cluster as well, and then the distance between the two will be the Watt's distance. So Watt's method tends to join clusters with a small number of observations, and it is strongly biased towards producing clusters with the same shape and with roughly the same number of observations. So if it is so, then it is good. If the number of say units are same for the different clusters, then it is going to be okay. Otherwise, it will be widely biased. Now, the hierarchical cluster analysis provides an excellent framework with which to compare any set of cluster solutions, because we will be having different cluster solutions by changing some say observations, say characteristics. So this method helps in judging how many clusters should be retained or considered. So the average distance is the key one, on the basis of which, if there is drastic change in average distance, then we'll stop there. Now we come to non-hierarchical cluster analysis. Here what we do, we fix the number of clusters, and then we start grouping the units. So in contrast to hierarchical method, the non-hierarchical cluster analysis do not involve the tree-like construction process. Instead, they assign objects into clusters once the number of clusters is specified. So first we specify the number of clusters, and then on the basis of the say distance or similarity measure, we put different objects in different predetermined, say, clusters, number of clusters. So two steps are there to form the non-hierarchical cluster analysis, non-HCA. First, we specify the cluster seed. How we will define these clusters, to how you are making. If you are say making 3 clusters, then how you will be merging, or you will be starting from where. So identify the starting points. So the 3 starting points you will have to choose, and on the basis of these 3 starting points, the similarity similar objects will be put there in the predetermined clusters. Now, so first thing is to define the seed points, say starting points, cluster seeds. And then another one is assignment. Once you have identified, say, 3 things, then all the rest observations are there. On the basis of similarity, we'll be assigning the objects in different clusters. So assign each observation to one of the cluster seeds. Cluster seed means the basic clusters. So non-hierarchical clustering algorithm involves sequential threshold method, parallel threshold method, and optimizing procedures. And these all are known by very famous name, that is k-means cluster. So all of these belongs to a group of clustering algorithm known as k-means clustering. So what is k-means method? This method aims to partition n observations under consideration into k clusters, in which each observation belongs to the cluster with the nearest mean on the basis of the characteristics under study. So the k-means is so commonly used that the term is used by some to refer to non-hierarchical cluster analysis in general. So on the in place of say non-hierarchical cluster analysis, we say k-means cluster method. So now there are some advantages and disadvantages of these techniques. So what are the advantages of say this hierarchical cluster analysis? So the simplicity is with this method. With the development of dendrogram, the SCA afford the researcher with a simple yet comprehensive portal of clustering solutions. We are having definitely different type of solutions, but still it is very simple to make the clusters. Measures of similarity. SCA can be applied to almost any type of research question. So on the basis of distance, we'll be merging the clusters. And now the very important thing is speed. So SCA have the advantage of generating an entire set of clustering solution in an expedient manner. It means in one shot we can make all type of clusters. But in non-SCA, you have to decide the first clusters, maybe a wrong decision. Suppose the optimum size is to make 3 clusters and you are making say 2 or you are making this 4. So it is better to perform SCA, and then after knowing the number of clusters, you should apply the non-SCA. This is what the people do in practice. So what is disadvantages? What are the disadvantages of SCA? To reduce the impact of outliers, the researcher may wish to cluster analyze the data several times to identify the outliers. Each time deleting problem observations are outliers. So every time we will be deleting the the outliers if they are not of importance. And hierarchical cluster analysis is not amenable to analyze large samples. If we are dealing with the large samples, say more than 1000, so it is not going to be very appropriate, because we have to first make say 1000 clusters, then we will be starting merging them. Now the advantages of non-SCA: the results are less susceptible to outliers in the data. The distance measure used and the inclusion of irrelevant or inappropriate variables. So we have less suspense there. It is not very susceptible in case of non-SCA. So non-hierarchical cluster analysis can analyze extremely large data sets. So if you are dealing with the data, say having more than 1000 objects, then we should go for the non-hierarchical cluster analysis. Now these are the disadvantages of non-hierarchical cluster analysis: that even a non-random starting solution does not guarantee an optimal clustering of observations, because if you are just removing the or including the say observations or units, then the cluster structure will be changed. So in fact, in many instances, the researcher will get a different final solution for each set of specified seed points. How is the researcher to select the optimum answer? Only by analyzing and validation can the researcher select what is considered the best representation of the structure. So there we get clusters in one shot in SCA, while you have to keep on repeating the analysis in non-SCA to get the optimum clustering. And realizing that many alternatives may be acceptable. So it is very hard to, distinguish between sometimes say 2 or more clusters solutions. So non-hierarchical methods are also not so efficient when a large number of potential cluster solutions are there. So each cluster solution is a separate analysis with a 3 cluster, 4 cluster, 5 cluster. Every analysis is a separate analysis, in contrast to the hierarchical techniques where we have optimum clusters that generate all possible cluster solutions in a single analysis. So thus non-hierarchical techniques are not as well suited to exploring a wide range of solutions based on varying elements such as similarity measures, observations included, and potential seed points. So on the basis of these 3 points, it is not very efficient technique to identify the optimum solution for the number of clusters. Now it is good to combine the two. Combination of the both methods. So a combination approach using a hierarchical approach followed by a non-hierarchical approach is often advisable. So it is better you perform first the hierarchical cluster analysis, and you get there the optimum number of clusters, and then by forming that much number of clusters you perform the non-SCA. So first, a hierarchical technique is used to select the number of clusters and profile cluster centers that serves as initial cluster seeds. So suppose if the optimum number of cluster in SCA is 3, so they will serve as the cluster seeds for non-SCA in the non-hierarchical procedure. So a non-hierarchical method then clusters all observations using the seed points to provide more accurate cluster membership, and it will also consider the outliers as well. So in this way, the advantages of hierarchical methods are complemented by the ability of the non-hierarchical methods to refine the results by allowing the switching of cluster membership. Now it is very important to the interpretation of the clusters. The cluster centroid, the mean profile of the cluster on each clustering variable. Clustering variable means the characteristic, each particularly using in the interpretation stage. So interpretation involves examining the distinguishing characteristics of each cluster's profile and identifying substantial differences between clusters, and that is similarity measure. So cluster solutions failing to show substantial variation indicate other cluster solutions should be examined. If we are not having, say, substantial variations, so that is why sometimes we perform say that ANOVA in SCA. After performing SCA, we also perform ANOVA to see the substantial variation in different say characteristics. So the cluster centroid should also be assessed for correspondence with the researcher's prior expectations based on theory or practical experience. So definitely these centroid clusters should be examined on the basis of the prior information by the researcher or say by the pilot survey data. Now validation of cluster is a must. Validation is essential in cluster analysis because the clusters are descriptive of structure and require additional support for their relevance. So cross validation empirically validates a cluster solution by creating two subsamples, randomly splitting the sample, we'll be splitting the sample and then comparing the two cluster solutions for consistency with respect to the number of clusters and then cluster profiles. So suppose you have splitted just the larger sample, and then we will be checking, looking for the consistency of the cluster analysis. Now validation is also achieved by examining differences on variables not included in the cluster analysis, say outliers, but for which a theoretical and relevant region enables the expectation of variation across the clusters, but theoretically they have some merit to be included into the analysis. Now how we will be performing the cluster analysis on SPSS? Very quickly we will be seeing this one, and then we will be doing hands-on on SPSS with the data. So type of clustering procedure: hierarchical cluster analysis, non-hierarchical cluster analysis, and the combination of the two, that is two-step cluster analysis. Now hierarchical cluster analysis, suppose we start with an example. This file only includes 20 cases, each responding to items on demographic, gender, qualification, and so on. We are attempting to determine how many natural groups exist and who belongs to each group. These are the characteristics, and we are having 20 observations, say 20 objects, and we will be making different clusters. So how many optimum clusters are there and which unit will belong to which cluster. Now to perform this analysis in SPSS, we will go to analyze, then to classify, and in classify you will see all type of analysis, cluster analysis are there. So that is a hierarchical cluster, k-means cluster, and two-step cluster. So we'll click on the hierarchical cluster, and there these 4 tabs are there: statistics, plots, method, and save. So we'll be clicking on say statistics or say plot, and every one by one we will be clicking on. So it has been clicked on plots, and there you just click on the dendrogram, and all clusters will be displayed there, and orientation we wish vertically, or you can have horizontally as well. So okay, now click on the method, and there are so many methods. You just click on say words method, and there are different distance measures there. So this is very common and very much used method, that is squared Euclidean distance, and you just select it from drag and drop list, and no standardization. Okay, no need of standardization, and then click on continue, and then click on OK. You will have the dendrogram this way. So here on the basis of the similarity, different steps are done. Now this is agglomeration schedule here. How one cluster is merged with the other one is done through this table. So here these are the distances, or say coefficients, on the basis of, if we are dealing with the say large and large data, then we rely on the coefficient, this distance coefficient, and the distance coefficient having lesser and lesser distance, we will start with the least distance. So here the agglomeration schedule is a numerical summary of the cluster solution. At the first stage, cases 7 and 9 are combined because they have the smallest distance. So here you can see the distance is say 4. So 9 and 7 are having the smallest distance, that is say 4. And the cluster created by their joining next appears in stage 8. Next stage is 8. This one. Here this 7 is added with the 5. This 7 is added with the 5, and here we can have the distances. No. Okay, we will see in example. So this way all the clusters are added. And then next stage is the observation 5 and 7 were joined. The resulting cluster next appears in 13. This one. This 5 is added with the 12, having say lesser distance. And when there are many cases, this table becomes rather long, but it may be easier to scan the coefficients column for large gaps rather than scan the dendrogram. So we will scan this, save the distance coefficient on the basis of the distance coefficient. So here, this is the table where we can have an idea that these are the agglomeration last step, say number of clusters 2, 3, 4, 5, and 6. So the agglomeration step, these are the coefficients and coefficient distance, and these are the coefficient and these are the change in the coefficients. So where we will observe the drastic change, there we will stop the merging the different groups, different clusters. So a good cluster solution sees a sudden gap in the distance coefficient. This is change. The solution before the gap indicates a good solution. 1000, 1090, 1000, and then 306. Then 248. So in table, this is a reformed table to see the change in the coefficients as the number of cluster increases. The final column headed change enables us to determine the optimum number of clusters. In this case, it is 3 clusters. As succeeding cluster adds very much less to distinguish between the cases. These are not very much distances. So here it is better to, form only 3. Because if you are making 4, there is very, less change. So now you can have a solution, you can save and you can unsave. You just go on single solution. If you are not having, say, multiple solution, do one single selection, then there you have to define the number of clusters, say 3. So this will be saved here. So which unit is put in the cluster? So first unit is put in first cluster, second in second cluster, then third in again first cluster, fourth in third cluster. So this way you can, make different groups, clusters with different observations. Now you go to the option and you just click on descriptive. Okay, so here we can now perform the one-way analysis, one-way ANOVA. So you go on, say, analyze, compare means and one-way ANOVA, and you put all the variables or units, say, here, and the cluster, all the observation in single cluster, say, Waltz method, we have just named here, and you put here in factor, and you just go on descriptive. So by clicking on continue and then okay, you will have a table of like this. So you can here, you can see all are significant, thus this is going to be non-significant because these are the p values and p value must be less than 0.05. But here it is 0.4, which is more than 0.05. So this qualification is not going to be contributing any variation in the data, in the units. So qualification did not produce any significant association. So it is not having an association with other variables, as you say, other characteristics. Now, how we'll be interpreting the cluster if you are dealing with, say, some categorical data, not scale, then we'll be putting these. So we'll be checking their the independence of attributes through the chi-square test. So here we will go to say cross tab and just you put the different characteristics in this row, and see here we have put all the 3 clusters units in a single column. So this will be put here, and you just put here all rest of the categorical observations or categorical variables, categorical characteristics, and we can have a cross tab. So this way you can check gender with Waltz method for all the 3 clusters. So gender wise you can have that and in first cluster there are 6 male and 1 female, total 7. And in, say, cluster 2 there are 8 gender and 8 male and, say, 1 female, and in cluster 3 only 1 male and 3 female. So this way you can have for the smoker and non-smokers as well. So there are 7 non-smokers in cluster 1 and no smoker is there. And in cluster 2 there are 6 non-smokers and 3 smokers. And in cluster 3 all 4 smokers are there and with no non-smoker. So this way you can form the check different categorical categories of categorical variables. So these are the descriptive things. Now we come to non-hierarchical cluster analysis, or say k-means cluster analysis. So here these are the characteristics of the observations or say objects under consideration. And to perform this non-SCA, we'll go to analyze, classify, and then go to k-means cluster. And this type of dialog box will be opened there. So you have to put all variables here, and you have to define cluster first. So since we are say making 3 clusters, so and then go to this iterate. So how many iterations are needed for the analysis? So 20 are by default it is 10, but you can say set your own and go to save and options all there. You can have statistics. You go to options there, you have the initial cluster centers and ANOVA table, then cluster information for each case as well, and exclude cases pairwise, and then click on continue, and then you will have this way the 3 clusters. So these are the distances, and they are the reiterated clusters. So the initial cluster centers are the variable values of the k well spaced observations here. Then again. So in all clusters, these are adjusted. So the iteration history shows the progress of the clustering process at each step. So yeah, these are the different iteration. This is formed through one iteration, then another iteration, then another iteration on the basis of the distance, optimization of the distances. So in your early iterations, the cluster centers shift quite a lot from this to this to this. By the you can see here for the different units. These are the number of iterations. These are the distances for the first iteration, second iteration, third, fourth, fifth, and so on. And last one, see here, it is going to be constant 0, 0, 0, 0, 0. So by the 14th iteration, so the result or solution is stable after say 14th or say we can say 14th or say 15th, because then next we are having 0, 0, 0. So by the 14th iteration, they have settled down to the general area of their final location, and the last 4 iterations are minor adjustment. These are. So and after that one you can see here, after 18 observations, all are 0. So all are adjusted there. So this way we can have the ANOVA. These are the different observations, say 14, and the all are going to be significant here, because p values are for all the variables, p values are less than 0.05. So the ANOVA table indicates which variables contribute to the most to your cluster solutions. The variable with large f values provide the greatest separation between clusters, greatest distance between the cluster. So you can see here the distances f value, or you can say just it must be significant. So on the basis of the large value of f, it will distinguish between the effective clusters, but having more and more distance. So here a final cluster. The final cluster centers are computed as the mean of each variable within each final cluster. Cluster 1, cluster 2, cluster 3. The final cluster center reflects the characteristics of the typical case for each cluster. These customer in cluster 1 tends to be big spender who purchase a lot of services on the basis of these say weights or observations, and these are going to be less, and these are going to be very less. So now you see this one and see this one. After iteration, the customer in cluster 2, this cluster 2, tend to be moderate. So on the basis of the similarity, they have, and all units have been put in different clusters. So these we can say that this group is going to be going to spend more in shopping, and this is moderate group, and this is a group with least expenses. So customers in cluster 2 tends to be moderate spender who purchase the calling services, and customer in cluster 3 tend to spend very little and do not purchase many services. So this way we can we have made on the basis of the differences the 3 distinct clusters of units under consideration, and on the basis of the characteristics they are having. Now distance between final clusters. So you can see here the distance between the final clusters. So distance between first and second cluster is 3.5, first and third cluster 4.8, and second and third cluster it is 3.3. So this 3.3 is very close to this one. It means second and third are very close to each other, but first one and third one is going to be different. So cluster 2 is approximately equal to similar to clusters 1 and 3. Cluster 1 and 3 are most different here. It is having distance 4.8 and the rest 3.3 and 3.5. So now here you can see the number of cases in each cluster. So these are the cases. Say this, and this cluster is having. It means there are so many persons with low income, we may say. They are not going to purchase big. A large number of cases were assigned to the third cluster, which unfortunately is the least profitable group for say marketing aspect. So perhaps the fourth more profitable cluster could be extracted from this basic service group. So we can make one more cluster. So in a non-SCA you just put 4 and you will get revised analysis. So now we have just made 4. Everything is similar, and now here we have 4 clusters. 1, 2, 3, 4. So you can see here. Now the distance 3.6, 3.6, 3.5. For the fourth one is with 1, 2, and 3. 4 and 1, 4 and 2, 4 and 3. So thus cluster 1 and 2 are the most similar, which makes sense because they were combined into one cluster in the 3 cluster solution. So 1 and 2 were merged with this one. So now they are similar, and it means the first one has been split in further 2 clusters. Now we can say the number of cases now almost similar. Now fourth one is having still 280, but 236, 272, and 212. So this when nearly 25% cases belongs to newly created group E services, say electronic services customer. We have just named it the cluster. So you have to name the different clusters, which is very significant to your profit. Now 2-step cluster analysis. What we do, we first do the SCA, and then we have the idea there how many optimum clusters should be made there. Then we perform the non-SCA there. So this way we can have this one, this one, this one. So 4 clusters are made there: poor, fair, and good. So this way we will be making this. Not very much used. We use the basically non-SCA after performing the SCA. So these are some graphs for that one. So this is all about today's discussion of cluster analysis, and I think now we should perform this analysis in SPSS, and then we will be discussing the things. We will be having some questions, some discussions. Okay, say we have a case study of, say, shopping mall. We consider a clustering of consumers based on attitudes towards shopping. Based on past research, 6 attitudinal variables were identified. Consumers were asked to express their degree of agreement with the following statements on 7-point scale. So we have 6 questions on 7-point scale. 1 strongly disagree and 7 strongly agree. Question 1 is, I love to buy products in shopping mall. I buy discounted products. I enjoy eating food at shopping malls. I bargain products when shopping. I buy only daily need products. I compare prices of products in shopping malls. These are the 6 questions. Okay, so we have, all 6 variables, and we have this data on 25 units. So now we will be performing SCA and non-SCA. Okay, so first we'll go to analyze, then classify, and then we'll go to hierarchical cluster. And here you have to select all the variables and you have to put here. Now you have to go to statistics, and just we are using, say, agglomeration schedule, and you can have idea of proximity matrix as well. And okay, if you wish a single solution, so then you have to decide the number of clusters. So here num, say okay, then we'll go to plots, then dendrogram we need, and vertical we need, and click on OK, and then we'll go to method. So here you can go for the, say, Ward's method, and squared Euclidean, no issue. And you click on OK and go to save. So we will be doing it later. Suppose if you wish to have single solution with the 3 clusters, so you have to define just clusters. But here we don't want, so we just we are having idea of, say, optimum number of clusters. So now we'll click on OK. So no need of this proximity table actually here. So these are the distances for all the, so this is Ward's linkage, you can see here. These are the number of clusters, cluster 1, cluster 2, and these are the coefficients. So on the basis of these clusters, you can say here, first 14 and 16th units are added, and then that 6th stage, this unit, 14 is added with the 10, then with the next stage, this way we will be adding the things. So here you can have idea. Numbers are non mentioned actually here. So you at first stages are not given here. Yeah, this is the first stage. So at first, the first, see here, first 17, 12, 21, 7 and 6, these units are added with each other. Then second, 28 and 8 are added with each other. Then where is third? Okay, yeah. Then third and 15 is added with each other. Then 4, 9, 25 and 11 are added. Then 5 and 20 are added on the basis of the distances. And then 6, 6 is already added. So next we will see here this the distance between 14, 16, 10. Okay, 10. So 10 is added with this. And then at next stage, the nearest one will be added. These two are added at next stage. Then this at next stage, then these, and then finally this one is added. So this way we can have an idea. So how many clusters should be made there? We can have say 1, 2 and 3. So this way we can have idea how many clusters should be made there. So suppose now we are just repeating it. Suppose we go to analyze and then classify, and we are just clicking on hierarchical cluster, and we are going on the method, say, okay, continue, then save plot. Say now we are going to have 3 clusters, and continue and click on OK. So this way everything will be there and you will have the 3 clusters solutions. No, clusters are not displayed here. We have left something. Let me do it again. See here, this one, say we have just named it, say, word method. So now we can perform the ANOVA. But before that, we wish to see whether anything is left there. Statistics. Okay. Okay, so single dot method is okay. Save is okay. Okay. So you can see here this way. Yeah, this cluster membership is there. So you can see which unit has been put in the different clusters. 3 clusters are there. So first, second, third, these are put in first cluster. Then fourth, fifth in second cluster. Then again 6, 7, 8 in 6, 7, 8 in again first cluster. So you can, if you are making the 3 clusters, you can see here. These are put in first cluster, then the second, and the other third cluster. So this way you can have idea from these 3 things. Now we wish to see whether all the variables are going to be significant in defining the cluster or not. So we have to perform the this. I mean, it is repeated. So now we will be performing the ANOVA table. ANOVA. So go to analyze, then compare means, and go to one-way ANOVA. So here you have to select all the numerical or say scale variable here, and you just this put in factor and go to contrast, say polynomial, and okay, postdoc, you can go for the, if it is written, you may go for the Tucky test, and say option, we need this descriptive. It is okay. You click on okay. So this way you can have this is the descriptive statistics, and these are the ANOVA table for this one. And see here, this is multiple comparison test because it is significant. All p values are, see here, all p values are less than 0.05. So it is significant. So now the two variables will be, which variable is responsible for the variation. And here we are interested that this hypothesis should be rejected. All p values should be less than 0.05 because to make the differences for different clusters. So this way you can have all the three clusters numbers are there, and how many numbers are there, and all the numbers are displayed in previous analysis. So this way you can have the idea. This Tucky test for pair of observation for different characteristics which are significant. Now to how to perform non-SCA. Go to analyze and classify, then go to k-means cluster, and you have to define all the here. And how many iterations? 10 if it is okay, otherwise you write 20 here and click continue, then save, say cluster membership and distance from cluster centers, click continue, and options. Say initial centers and say cluster notable cluster information for each case. And you can have exclude pairwise and click on continue. Number of clusters, say 3. Okay. So this way these are the 3 clusters, and this is iteration history. Only 2 iterations are needed. Say here the 18 iterations were there in the discussion, and here in only it is optimized at 1. Only 1 iteration is there, and these are the distances, and on the basis of the distances all these 25 units are clustered in 3 clusters. So this way you can make the clusters. So final cluster centers are, these are the distances for average distances for all the characteristics. So now you can see the distances from all the clusters, so that we can have idea which one is close to that one and which one is going to have. So second and first is having 6.5 distance, and first and third is having 5.1, and first and second and third is having 5.6. So these all are having some reasonable distances. So here you can see all the variables are significant which we need, because and distances are given on the basis of the more and more value of the F statistics. So we can have the idea of the distance between the clusters, among the clusters, and all are significant. So this way you can say 3 clusters are there, number of clusters you can see 8, 10, and 7. So this way 8 units are in the first cluster, 10 units are in the second cluster, and 7 units are in the third cluster, and these are the distances. On the basis of the distances the units have been assigned in different clusters. So this was all about today's discussion. If you have any query, any question, you may ask, and if you wish to since we are not using here the categorical, so it is not going to be very all the variables are to be put here in continuous, but if you are having some categorical variable, you have to put here and then go to option and then use noise handling. So 25%. So here okay, and output. So no variables are shown here because we are not dealing with the categorical variables. So you click on OK, so you will have some idea of this 2-step. So 6 cluster 1. So it is making only 1 cluster is poor fair, and 3 clusters are made in this. So better to use the CA, then non-CA, you are using the non-CA. So now if you have any query, any question, please ask. Otherwise, we should leave.
Thank you, sir, for your informative session. Now the session is open for queries. So you can ask your queries by writing in the chat box.
Yeah, PPT will be given to the organizers and you will
Yes, they will forward it to you. So you can ask or you can unmute yourself. Or you can also write.
PPT along with the I mean hands-on data.
Yes, data set that we need.
Yeah. You practice and do it.
Sir, how do we express the results in this example?
You can make your own table, ma'am, on the basis of the units, and then you will have to name the cluster on the basis of the characteristics. That what we have done in the example, that the group with more, I mean, which the group is spending more, it is investing more, and it is moderate, and this is the least one. So this way you have to define you have to name the cluster as we do in factor analysis. We have to name the factor.
Okay, so it is the knowledge of whatever we had, whatever our question, and the basic review of literature and the
Definitely. So
Yeah,
on the basis of the basically characteristics under consideration, you have to name that group particular.
Okay. Thank you, sir.
Okay.
Sir, is it essential to do both factor analysis and cluster analysis when we are doing a tool development?
First, we should work on factor analysis, then cluster analysis. Because
Both should be done.
First you have to make the I mean distinct variables characteristics, because so many, if you are dealing with the same characteristic with different names, so this will not be going to be very good. Suppose I am just asking one question, what is your name, and the another question is by which name your father call you. So that is this type of I mean variables are done in are put in one group, and that group is named something else in factor analysis, and that is known as the factor. Yeah, principal component we call that. It is principal.
Can we call it domains, sir? Like
yeah, definitely
domains. Yes.
Generally, well accepted name is that is principal component. You can call it domain, group.
So for testing this tool, new tool, how many samples we should have? We have developed a tool for now testing it.
Same, I mean, it must be a reasonable number. Or you may say, if you are using, if you have made some tool and you wish to apply, then a reasonable number of observations should be there to cover the population. At least every type of population unit should be in the sample unit. Otherwise, on the basis of the hypothesis, you just calculate the sample size determination.
Like we have cystic fibrosis, very few patients are there. We have only 100 registered patients with us.
So 100 maybe 100 is sufficient.
Okay. Thank you, sir.
I think no more question.
No, sir. I think there are no more questions. So Thank you so much, sir, for your informative session, and thanks to all the participants for patiently listening the session.
Someone
we
is
will-
asking for, medical example. So you should make the example by your own medical people. And just like you are having some patients and you are say having their vital parameters. So on the basis of the vital parameters, you can identify different group of patients.
Yeah, the idea is same for everyone. It doesn't matter how, from where you are taking the data. It may be agriculture data, it may be social science data, or it may be
Definitely.
medical data.
The essence is that you have to define the characteristics, and on the basis of all the characteristics, you have to group the units, objects.
Yes, yes. So thank you so much, sir, for your very smooth session. You have covered this very complicated, topic in a very smooth way. Thank you, Sushil, sir.
Thank you to everyone for listening very peacefully, and we enjoyed the session. And thank you to the organizers, Dr. Sushil Shukla
Thank you very much.
from SEFI, and
Thank you, sir. Thank you.
so we'll be meeting tomorrow.
Yeah, sure. So tomorrow's session will be on the discriminant analysis.
Yeah.
So we'll meet tomorrow. Thank you. Thank you all.
Thank you,
Thank
and
Thank you.
good night
Thank
to
you
all
all.
of you.
Thank
Good
you.
night. Bye-bye.
Good night, sir.